Hello everyone. So today I am going to start with the lecture on fluid mechanics. Okay, so this is one of the important subjects in civil engineering or mechanical engineering. Okay, so I will take into consideration all the important aspects of fluid mechanics as per civil engineering point of view. Okay, so before moving into the details of the subject, let us take a introductory session on this fluid mechanics. Okay, so I'll give you a brief detail about the subject first, then we'll move into the core part of the subject. So before starting fluid mechanics, let us discuss briefly about your mechanics first. Okay, so you know that there are very many physical laws that governs the life on this earth. Okay, so for example, gravitation. Okay, so this is all these all type of phenomena that occur. They directly depends upon the forces and impact of forces. Okay, so what is mechanics? Mechanics is the science concerned with the motion of the bodies under the action of forces or bodies at rest. Okay, so in brief, what is mechanics? Mechanics deals with the forces and its impact on the body. Okay, so now what is engineering mechanics? So engineering mechanics is the application of mechanics to solve the problems involving common engineering elements. Okay, so like fluid mechanics, okay, like solid mechanics. So what we are doing, we are applying the mechanics to engineering problems so that we can get some solutions for the problems. So that is termed as engineering mechanics. Okay, so each object, okay, like solids or a liquid or large or small, it responds differently under different conditions. Okay, so engineering mechanics examines these external forces by studying statics, dynamics, material strength, elasticity, and fluid dynamics. Okay, so in simple terms, we can say that it is a bridge between theory and application. Okay, so I hope you have got a clear idea about mechanics first. Okay, so it is just about the involvement of forces on any object. Okay, so let us take into account the different branches that are that we study under mechanics. Okay, so there are three branches. First one is your statics, second one is kinematics, and third one is kinetics. Okay, so this is very much important in physics. Okay, so in physics, mechanics is a separate branch, okay, in which we divide it into three categories: statics, kinematics, and kinetics. Okay, so what is statics? Statics deals with the forces acting on and in a body at rest. Okay, statics means anything we study in anything that we study at the position of rest. Okay, so that is termed as statics. Now what is kinematics? Kinematics, it describes the possible motion of a body or a system of bodies. Okay, so when we talk about motion, okay, so then that is termed as your kinematics. Okay, and what is your kinetics? So kinetics, it is just an attempt to explain or predict the motion that will occur in a given situation. Okay, so there are these branches. So if we consider an example, okay, so let's have this pen. Okay, so for this pen is currently, it is at rest position. Okay, so there might be several forces acting on this pen at this point of time. Okay, so whatever the impact of the forces is on this pen at this point of time. okay, at the position of rest. So that we study under statics. Okay, so when we apply some external force to this, okay, it does, the pen starts to move. Okay, so it is under kinematics. Okay, so and what is kinetics? Kinetics means when we try to predict the motion of this pen under certain situation. Okay, suppose there is a situation where your temperature and other things that influence the properties of this pen, okay, they are fixed, and then we are studying the motion of this pen. Okay, so now what is so let us take into account there are three types of matters. Okay, we have solids, liquids, and gases. Okay, so now the solids, what we do, we study the impact of forces on solids. Okay, so that we study under solid mechanics. Okay, and liquids and gases, they are termed as fluids. Okay, so this, when we study the impact of forces on liquids and gases, okay, so that we study under a different branch that is called fluid mechanics. Okay, so these are termed as fluids. Okay, so now what is the basic fundamental difference if we talk about a engineering perspective view? So what is the most fundamental difference is that solid mechanics govern by stress strain law. Okay, so that is your Hooke's law that we say, okay, in solid mechanics, while fluid mechanics is governed by stress and rate of strain law. Okay, so this is the basic difference. We'll study in detail about this in the further lecture. Okay, so now the mechanics of fluid, let us consider the differences and similarities between the mechanics of fluids and solids. Okay, so what are the differences? So here you can see fluids and solids. Okay, what are fluids? Fluids, in fluids we take for example water and air, both are your fluids. Okay, so fluids have no shape first. Okay, and while solids have definite shape. This is the first difference. Okay, and second one is fluids cannot sustain shear force. Okay, so that is, the fluid is always in motion. Okay, so you can see if I put this pen on this table, okay, and if I spread water on this table, okay, so what will happen? This solid, it can sustain a shear force. Okay, but while your fluid cannot sustain shear force, it starts to flow whenever I spill the water on the table. Okay, so this is the thing. So now what the next difference is, stress is a function of a rate of strain, thus fluid had a dynamic state. Okay, so in fluids, stress is directly related to your strain rate. Okay, while in case of stress in solids, your stress and strain stress is a function of strain. Okay, not rate of strain. Okay, so rate of strain means it is continuously deforming. Okay, whereas in case of your these solids, they do not continue deform. Okay, so now the static properties of fluid cannot be extended to dynamic properties. Okay, and while the static properties of solids can be extended to your dynamic properties. Okay, so these are some differences, but there are some similarities also. Okay, so there is a continuum hypothesis is used for both fluids and solids. Okay, so what we consider a particle is continuously distributed. Okay, so there is no any space considerations that we take. Okay, so in both the cases, that is fluids and solids, we take a continuum hypothesis. Now next one is your fundamental laws of mechanics apply for both for fluids and solids. Okay, so what are your fundamental laws of mechanics? That is Newton's law of motion, okay, that is conservation of momentum and conservation of mass, and first law of thermodynamics, that is conservation of energy. Okay, so these all laws are applicable to your both solids as well as fluids. Okay, so fluid is a body whose particles move easily among themselves. Okay, so that's why fluid is a generic term, and it includes your liquids and gases as species of. Okay, so water, air and steam, these are your fluids. So whereas your liquid is being in such a state, okay, so liquid is a state that the component part move freely among themselves. Okay, so the molecules, they move freely among themselves but do not tend to separate from each other as the particles of gases and vapors do. Okay, the molecular distribution in case of gases and liquids, they are different. Okay, so in case of gases, the molecules are very much far apart, and in case of your liquids, your molecules are very much close to each other. Okay, so this is the difference between gases and liquids, whereas gases and liquids both comes under the category of fluids. Okay, so this is all about this video. Okay, in the next video we'll discuss different branches of fluid mechanics and what are the different properties of the fluid. Okay, thank you so much.